Okay, listen up. I need urgent assistance. I need an astronaut, but not just any astronaut. I need one of the persons that is currently in the International Space Station. So if you have their mail or know somebody who does, please send them this video. I need you guys to do a very simple experiment. You will be able to do it with stuff you have hanging around, like a large plastic bag and a lot of duct tape. If the experiment works, as I know it will, your next gig may be going somewhere instead of just going round and round and round the planet. You will need a small motor, a little propeller, and a battery. Put the motor and propeller inside the bag, inflate the bag, and turn the propeller on. When the propeller spins, it will push the bag from the inside and it will propel it in the forward direction. When we suggest this experiment, there are two reactions. One is, "Are you crazy?" and the other is, "Who cares?" First, we shall address the persons that say that is crazy. We and others have done this experiment repeatedly. It has been verified by others. Why does it work? It is very simple. But first, remember that inside the bag there are billions and billions of fast-moving molecules colliding with each other. When the spinning propeller collides with one of the air molecules, it will exert a strong force, accelerating it towards the rear end of the bag. As for every force, there is an equal and opposite counterforce. The propeller will also receive a force pushing it in the forward direction. If the molecule that was expelled in the backward direction is lucky enough to reach the rear end of the bag without interference, then the forces will be equal and the bag will not go anywhere. But in all probability, the molecule will collide with millions of other molecules when it is trying to reach the rear end of the bag. Let us talk about the molecule's momentum. Remember, momentum is not a thing. It is not an entity. It is simply the product or the multiplication of the molecule's mass times the molecule's velocity. When two molecules are about to collide, they each carry their own individual momentum. We can add the magnitude of both momentums to momentum sub t. When the two molecules collide, they do not suffer any change in their mass. However, their individual velocity may change. If, for instance, the velocity of molecule M1 increases, then the velocity of molecule M2 will decrease proportionally, because the sum of their momentums must always be the same. There will never be any change in the sum of the momentum when two molecules collide. Momentum is not only velocity times mass. It is a vector. We must also describe its direction. We describe its directions by a three-dimensional graph. However, when the two molecules collide, we have no way of accurately describing, predicting in what direction the molecules will go. In fact, it is safe to assume that the molecule's direction is randomized. Therefore, some molecules will not reach the end of the bag or will not cause by interaction another molecule to reach with the same force. Always. Some of the momentum will go towards the sides, and that is how we unbalance the momentum and we can advance, pushing from the inside. I know it sounds absolutely crazy. We have been taught since grade school that a box or closed system cannot push itself from the inside. We have been taught that the laws of linear momentum are unbreakable. And yet we here have constructed the apparatus and it works again and again. It has been tried by others in Australia and the United States. And if you sit down and think about it, it is absolutely logical. If you take the time to do this simple experiment, you will go down in history. And maybe your next trip will not be around the world, but actually going somewhere. As for those who questioned, so what? What is this useful for? Who cares? That will be another video, because this video has already been too long already. Thank you very much, gentlemen of the International Space Station. Have a good trip back.